Welcome to The Explainer. Today, we're diving into a really fascinating, deeply mathematical framework for keeping powerful AI systems in check. It's called Certifiable AI Safety Theory, or CAST for short, and it's all built around 11 key ideas that are honestly pretty cool.
I mean, this is the question, right? It's one of the biggest challenges in tech today. You see, as these AI models start getting their hands on tools, like being able to write and run code or browse the web, the potential for things to go wrong just explodes. So the real trick isn't just cleaning up messes after they happen, it's stopping them from happening in the first place. So how do we tackle this massive problem? Well, we're going to walk through those 11 key ideas, and we've grouped them into four main parts to make it easy. We'll kick things off with the challenge itself, then we'll peek inside the safety gate, see how they make the system super robust, and wrap up with what this all means for the future. All right, let's get into it. First things first, we need to really understand the problem we're trying to solve here. First up, here's our first big idea. Look, this is not about science fiction. We're not talking about some super intelligence from a movie. The whole idea here is designed for what the paper calls the early 2026 class of AI. Think about systems that can actually use tools to interact with the world. The risk isn't some far-off thing, it's right around the corner. And that leads us straight to our second big idea. Just, trying to train an AI to be nicer or more helpful, that's not going to cut it. The goal of CAST is to have a real-time, proof-based safety system. The paper uses this fantastic term, finance grade, and it's the perfect way to think about it. We need the kind of hardcore mathematical risk management that big banks use to avoid total meltdowns. Okay, so now let's get to the really good stuff. How does this safety date actually work? This is where the whole thing gets super elegant. And this is our third key idea. The secret sauce is that safety isn't some vague, fuzzy concept. It's a mathematically defined safe set. The best way to picture it is like a digital playground with very clear fences. Any move or action the AI wants to take has to be inside this playground. Basically, it creates this really simple, unbroken, safe zone. There are no weird holes or gaps where something bad could slip through. And check this out. This slide gives you a perfect visual. So that green box, that's our safe set, our playground. If the AI suggests an action that's outside of it, like that red X, the system doesn't just crash or say no. It does something really smart. It mathematically projects it. It finds the closest possible safe action on the edge of the playground, that's the blue dot, and uses that instead. So it's not just blocking, it's intelligently correcting. Now, how does this all happen in real time? Well, it's all governed by our next big idea, this powerful three-step loop they call the master equation. It happens for every single decision the AI makes. Step 1, the AI suggests something to do. Step 2, the safety gate instantly checks if it's inside that safe set. And step 3, the system acts. It either lets the original action through, uses that repaired version we just talked about, or switches to a backup plan. And that backup plan is our next key point, because what makes this system so strong is that it's designed to fail safely. It has a couple of great options if an action is unsafe. There's projection, which we just saw, the smart fix, or it can fall back to what's called a dummy response. This is just a pre-programmed 100% safe action, like saying, sorry, I can't do that. Okay, so that's the basic loop. It sounds pretty solid, right? But what about a really clever AI? One that might try to outsmart the system or find some kind of loophole? This brings us to our next big idea. CAST is built to be super versatile. It can work with white box systems where you can see everything going on inside, but it also works for black box systems where the internals are a mystery. For those black boxes, it gets really clever. It uses statistical tricks like shadow sampling. You can think of it like sending in little probes, carefully designed inputs to see how the AI reacts, letting you test its behavior without ever needing to see the code. And here's a crucial point. The whole system isn't built on just trusting the AI to play fair. Instead, it's about building a fortress of trusted, auditable architecture around the AI. They call this the monitor capability contract. This means having stuff like untamperable logs, using random numbers that the AI can't see or predict, and, this is a big one, the ability to just hit pause and inspect exactly what the model is doing at any given moment. All right, now for our next idea. And this one is seriously cool. Think about it. A single action might carry a teeny tiny acceptable risk. But what happens when the AI makes a million or a billion of those actions? Those tiny risks can add up, right? Well, CAST introduces what it calls a global risk budget. It's exactly like a financial budget, but for risk. The system has a total amount of acceptable error it can spend. And you can see on the graph, it can spend that budget in different ways. The bottom line is, it makes sure that a bunch of small risks never snowball into a massive failure. And the next idea here is all about being practical. Because let's be real, modern AI systems aren't just one single thing. They're a mashup of different models, tools, and APIs all working together. So CAST is designed to be modular. You can prove that each individual component is safe, and then you can combine those safety certificates to guarantee the safety of the whole system. It's like building with Legos, where you know every single brick is solid. All right, let's wrap this up by taking a step back and looking at the big picture. What does a system like this actually promise? And maybe even more importantly, what are its limitations? This brings us to our last big idea, and it's a really honest one. The authors are upfront about the fundamental trade-offs here. It's something called the verification trilemma. Basically, for any complex system, you can pick 2 out of 3, but you can't have it all. You can't have rules that describe everything, cover every possible case, and always get you a quick yes-no answer. So CAST makes a smart, practical choice. It prioritizes getting you a fast, provably correct answer for the specific safety rules you define. And this quote from the paper just nails it. You can hear how grounded and practical the whole approach is. Again, this isn't about sci-fi scenarios. It's a finance-grade containment system for the kind of AI we have right now and are building for the near future, working with rules that we humans write down and define. So what's the bottom line here? What's the ultimate promise of CAST? Well, it's not about getting to zero risk. That's just not possible in the real world. It's about doing something much, much more valuable. It's about taking this big, scary, unknown risk and transforming it into something you can actually measure, audit, and manage. It turns the unknown into the known, which of course leaves us with the big question. By building safety right into the core architecture of the AI, not just tacking it on at the end, CAST really does lay out a compelling and mathematically solid roadmap for building AI systems that we can genuinely, verifiably trust.